Okay, so the quick review for dividing radicals. And first off, you have to remember the rule here. If you have a fractional radicand, you're able to split up that radicand into the nth root of the numerator divided by the nth root of the denominator, whatever that index is. All right, so let's do a couple problems here. So what about something like this? You got the cube root of negative 27 over 20n. So we can split this up. So we're going to have the cube root of negative 27 over the cube root of 20n. All right, you can have a negative radicand with an odd root. And so the cube root of negative 27 is actually negative 3. So that's our numerator. Now, what's going to happen on the denominator here? Well, we have a cube root. A 20 is a 4 times 5, and a 4 is a 2 squared. I need to rationalize the denominator. I need to get rid of the radical in the denominator. You're not allowed to have radicals in the denominator. So I need to multiply this bottom, right, by the cube root of, I have two 2's, right, 2 squared. I need 3 to take the cube roots. I need one more. I only have one 5. I need 3, so I need 2 more, 5 squared. I only have one n. I need 3. So that's got to be n squared. Whatever I multiply times the bottom, I multiply the same thing times the top. Okay, so what is my denominator going to be? I get a 2 out for the 3 2's. I get a 5 out for the 3 5's. So that's going to be a 10. And I get an n out for the 3 n's. So I get 10 on the bottom. Okay, and so the top's going to be the negative 3 times the cube root of 50n squared. And there you go. So negative 3 times the cube root of 50n squared over 10n. If these would have reduced, I would have reduced them, right? Anything out you can reduce. You can't reduce with something inside the radicand. Okay, so let's do one more. And again, here I have an imaginary number, and with that, a radical in the denominator. And I have to rationalize the denominator. And what you must remember is to rationalize the denominator is to use the conjugate. So I need the conjugate. So that'll be the square root of 2 plus 5i. See how we're forming a difference 2 squares? Whatever I do to the bottom, I got to do the exact same thing to the top. But it's the bottom where you're looking. It's the bottom that's your concern. It's the bottom that drives the top. Okay, I always like to do the bottom first to see where I end up. So because it's a difference 2 squares, we can do the shortcut. Square root of 2 times square root of 2 is a 2. A negative 5i times a positive 5i is a negative 25i squared. But always remember, an I squared is a negative 1. So we end up with 27 as our denominator. Now we got to deal with the numerator. Okay, I'm going to do it up above. So we just got to distribute its two binomials. 5 times the square root of 2 is 5 times the square root of 2. 5 times a 5i is a 25i. Square root of 5 times square root of 2 is square root of 10. And square root of 5 times a 5i is plus 5i times the square root of 5. None of these things add up. The only thing I want to do is group my i's. And if I really want to be technical, I could factor out the I. So that's the only thing I would do here. But for time's sake, 5 times the square root of 2 plus the square root of 10. And again, if you were to factor out that I, but you can leave it 25i plus 5i times the square root of 5. You might say, well, what would that look like if I factored out the I? So you would just go 25 plus 5 times the square root of 5 and then the I in the back, right? That's all. So that right there would replace that portion right there. All right? And that's probably a better final answer. So, but the key here was refreshing your memory on how to rationalize the denominator. All right?